Hello, today we are going to be talking about the normal curve and the empirical rule, and then we're going to be looking at the standard normal curve or the introduction to it later on. What is very important to begin with is that today will not make sense without having done statistics 1. So statistics 1 must be completed before you attempt to understand what we're going to do today, because it is totally based on it. Now, the key things in statistics 1 that you need are near the end. So mean, standard deviation, continuous histograms, so histograms and continuous histograms, distributions, and that I think are the main parts of it. So effectively the second half of statistics 1 is what today is based on, and nothing we do today will make sense if that isn't already understood. So I'm going to begin with a brief introduction to what's called the normal curve, which is something that gets mentioned in the distributions part of statistics 1. And where it comes from is if we run lots of different experiments, and I've listed a very common example here. If we had the height of all 6th year students in our school and we did a histogram of that, so we'd have unusually short people down here, we'd have unusually tall people here, and we'd have the mean sitting somewhere in the middle. For lots of situations like height or weight or lots of, we say, randomly distributed factors, we end up with a very similar shape to our histograms, that they rise in a fairly consistent hill or bell like shape. So you might have sometimes heard of this as a bell curve instead of a normal curve. So if you've ever heard that in daily language, bell curve and normal curve are the same thing. In maths we use the word normal curve. Now this is again a histogram of a proposed experiment of finding the heights of all of our different 6th year students. So there are very few people who are very, very short, and there are very few people who are very, very tall. Most people are around average height, and we know this from when we used to be walking up and down the corridors. We'd see that lots of people in 6th year would be around the same height, and we would have some students that would be quite short and some students that would be quite tall, but the vast majority are around the middle, are around the mean. And in terms of a normal curve, we find that this is actually very symmetric. So if we come down to here, this is more what your curves are going to look like in terms of exam questions, and this is a continuous version of a histogram. So if we broke up our bars of our histogram into very, very fine little bars, very narrow little bars, we would end up with these steps breaking down into a very smooth curve. And if we just did the tops of our bars instead of drawing all the vertical lines in, we would end up with this smooth curve, which you can see follows roughly the same pattern as my sketch here of our cruder histogram. And we have the mean is where, in this case, where most people are going to be. So our mean here, because this is a symmetric distribution, like we learned in statistics 1, that means that the mean, mode and median are all going to be in the same place. So in this case we're just going to talk about the mean as being the center of our data set here, and it's going to be the same as the mode and the median. That is going to be where most people, this is the height of most people, and it's going to be the average height. And out here we would have unusually tall people, and down here we would have the very small number of unusually small people. Now this symbol here should be familiar to everybody. It is the standard deviation, the average distance of our data points away from the mean. So remember, our standard deviation is the average distance away of our points from the mean. And one of the things you're required to know by heart, even though we look at a much more rigorous way of finding these things later on in our course, you are required to know something called the empirical rule, which is if you have a normal distribution, so we have our bell curve within my ability to draw, we have the mean in the middle, and if we start at the mean, whatever the mean, we'll say that it's height, so whatever the mean height is of our population, of our 6th year students, if we go the mean plus the standard deviation up in our group and the mean minus the standard deviation down in our group, this part of our bell curve is going to be 68% of our total population. So 68% of all of our students in 6th year are going to be plus or minus 1 standard deviation away from the mean or the average height. And you're required to know that number 68% by heart. They don't have to tell it to you in the exam. You're required to know it by heart. Likewise, you are also required to know by heart that plus or minus 2 standard deviations away from the mean. So if we start at the mean and we add 2 standard deviations and take away 2 standard deviations, from this height up to this height is going to contain 95% of the students in 6th year. And finally, if we go all the way out to plus or minus 3 standard deviations away from our mean, we are going to have 99.7% of our population. Now, not only are you required to know that by heart, these 3 diagrams exactly by heart and how to use them, you also have to keep in mind that this is a rough estimate only. We are going to learn a much more accurate way of finding exactly what percentages are between plus or minus 1 standard deviation and so on. But you're required to know this empirical rule, this rough estimate. They can ask you exam questions and require you to use this rule, even though you are required to know a more accurate way of doing it later on in the course. So we're going to start here with our empirical rule, and we have to know these 3 facts here. Now, this actually contains more information than may be particularly obvious, because we know that these curves are symmetric. Because we know they're symmetric, we also know that from the mean up to plus 1 standard deviation away from our mean is going to contain 34% of our population. So from our mean up to plus 1 standard deviation away from our mean, so this area here, must contain 34% of our population. Why? Because this is a symmetric graph and 68% are within plus or minus 1 standard deviation from our mean. That means that half of it must be above the mean and half of it must be below. So half of 68% is 34%. And likewise with our other 2 graphs here, we know that half of this group is going to be above the mean and half is going to be below the mean. So with all of that said, let's do an example and see this type of question in practice. So we are going to look at